Hey guys, Bart from TST Industries here. In this video, we're going to show you the installation of these TST Industries LED flush mount turn signals on a Kawasaki Z125. These signals come in a choice of a clear or smoked lens. They are packed with 15 bright LEDs on each board, and they make a really nice replacement for these bulky stock signals that Kawasaki mounted on this bike. Each signal terminates in a pair of male bullet connectors. And if you don't want to do any sort of wiring on your bike, we have an optional accessory called the harness converters that terminate in female bullet connectors on one side that enable this plug and play connection. And on the other side, you have a Kawasaki plug that will enable you to just plug this right into the plug that's left behind by the removal of the OEM signals. This is a very, very simple installation on this particular bike. We'll walk you through it step by step. Let's begin. So for the first step, we'll need to remove two screws that hold the headlight and shroud assembly on. They are just behind these stalks here. I'm using a 5mm Allen key for that. Sort of a cumbersome area to get into with fingers unless your fingers are really small. I'm having issues reaching in there. So I'm going to help myself with a pair of needle nose. And the screw head looks like this. I'm going to jump around to the other side of the bike. Perform the same removal. Now on this side it gets quite a bit easier because you can actually, at this point, move around the bracket that holds it. But in order not to drop this screw, I'm still going to use a needle nose plier. Just makes it a lot simpler. Same screw. All right, so now that we have this free from the bike and it's able to swing open, just got to make sure that you don't drop this whole assembly. It pivots on these pins here on this bracket and rubber grommets. I like to keep them on because it makes my life a lot easier during this installation, but you just have to make sure that you don't manipulate this in a way that it drops on you. So now let's identify the plugs that we'll be removing. You have on the right, you have the gray. On the right you have, on the right you have gray, on the left you have black. You need to remove the signal plug from the harness plug. So what I'm going to do is press on the lock. And that will enable me to take that plug out. That was a little better. And do that on both sides. And now I can get to actual removal of the OEM signals. I'm going to grab a flathead screwdriver, which will make my life a lot easier here. And we'll pry up on the steel brackets here. This is the steel bracket I'm talking about. It has a screw through it. What we can do is just get it in between the bracket and the rubber boot here. Pop it out. Once that pops out, we could take it off. Now we will grab the signal, twist, and pull. And that releases it. It's that simple. I'm going to repeat this on the left side of the bike. At this point, we are ready to install the TST signals. All right, so now to proceed with the mounting of the TST signal, there's a longer side and a shorter side here. We're going to go shorter side to the front. Insert the signal through the well. And then the nut that came with the kit, we'll put it onto the wiring with the flange side first. and start threading it on. And as you can see, the void left behind by the OEM signal is pretty large, so you have a lot of adjustability here on this axis of the signal, and also forward, backwards, and a little bit wiggle room up and down. So what I'm going to do is come down here and just make sure that my signal is following the body lines here and it looks good in its location and center, not hanging over any of these edges here. We want the entire surface, the entire back surface of the signal backed up against this shroud. And also you want it to be pretty level. This is pretty much up to you, really. I'm telling you how I like to install these. You can mount them on an angle if you like. And now once I have them in position, I'm just going to lock them down. You notice here I'm not using any tools to lock this down. We're working with nylon fasteners. They can only take so much load before they deform and not work anymore. So I'm not going to use pliers or a wrench on this. I'm just going to get it finger tight, just tight enough to make sure that vibrations don't displace this signal. And now I will move on to plugging in our optional harness converter. These are optional. If you'd like, you can probably just snip off the ends of the OEM signals and wire into here, and you still retain that plug. What I like to do is always use these because they take much less effort and much less time and make for very clean plug and play professional installation. Color coded, yellow to yellow, black to black. And you slip these insulating covers onto the conductors, and finally have to lock them in place. They do have the ability to move around a little bit during writing vibration. You can have them slip off and then they will likely touch together and cause a short circuit, blow a fuse. So we don't want that. We'll just lock them in place with either high quality electrical tape or harness tape, whatever you guys have in the shop. Point being is that you definitely do want these locked down. The insulation comes from the insulating caps. The tape locks it in place. Now, since this is substantially longer than the OEM system, what I'm going to do is route it underneath here and around these two positions, around these two features that mount the OEM plugs, just to make sure I don't have wires hanging out all over the place. And then plug it in. And if you guys watch any of my other videos, you know that at this point I like to test the system, make sure that I don't go any further without knowing that this is actually working. As you can see, we're good on this side. We'll move on to the left side and perform the same procedure on that side. So now, as you can see, the signaling system is flashing much faster than in OEM trim, and that's because we've replaced the OEM signal with an LED type signal that draws much less current. This is very typical on these machines. This particular bike is so sensitive to changes in signaling current that if you were to replace the rear with an LED type signal, then the signaling would stop flashing and it would just be stuck on constant. So what we've done here is we've developed a relay that plugs in to a wire taken out of this plug here. And we have a separate installation video for that particular part. Just wanted to let you guys know that that is an option. Another option is also wiring in a set of load balancing resistors that basically balance out the load that you're putting on the system. What that means is you're drawing much more current with the resistor in parallel with each one of these signals. The problem with using resistors is that now you have to wire in 2 wires for each particular lamp. So if you're doing 2, you'll have to have 2 resistors. For the rear, you have to have 2 additional resistors. That creates more bulk behind here, and now you have to mount it in a way that the heat created by the resistor will be sunk into a component other than a piece of plastic, because then you're running the risk of melting the plastic. So this is a simple plug and play device, and I believe it works much better than a resistor. Look for that video next. We will have it up shortly in our LED flasher relays playlist. Besides that, we are pretty much ready to close this up and finalize this installation. Okay, so to finalize this assembly, we will take the screws that we took out of this forward portion, and we will line up the tab here on the front of this assembly with the boss here, the tab being to the outside and the boss being to the inside. And once we line that up, we can start threading that screw in. Just have to make sure that none of the wires are impeding your ability to close this and put it in the right position, and I've done that here. So I'm going to take my Allen key and get that screw in there and manipulate the front end here to make sure that the hole in the tab and the thread in the boss is on the same axis. Once I've done that, the screw will penetrate in, and I will thread it in, bottom it out, take it out half a turn. We don't want that tight yet. I want to be able to have some maneuverability here to line up the other side. Basically just gonna repeat the procedure on this side. Again, once you close this up, it's a pretty cumbersome fit. So I'm gonna use my needle nose pliers once again. Once I have my screw in position, grab the Allen key again and start manipulating the front until I find that coaxial condition. And we're good here, it's threading in. Now we can tighten it back up. And that's it. This installation is complete now. I'll just do a final check on both sides, making sure that it works well. And the bike is ready to go. Hope you guys check out more videos by us. If you have any questions, concerns, comments, please place them below in the comment feed below this video. See you guys next time.